We're back. Oh, I don't have my loudspeakers plugged in. That's why I didn't hear the ding. Okay, now we're back, I think. I called this lesson 6.5. I added this about 3 years into doing Physics 12 because if you asked me to list the top 5 topics that kids found the toughest, momentum with angles was in the top 5, maybe top 3. So this is a continuation. If you were away on the Monday of last week before Christmas, again, if you haven't watched the video lesson, you really want to watch the video lesson, but hopefully I'm going to be, again, kind of fine-tuning. You can have your formula sheet, although the only formula you're really going to need to know right now is momentum is mass times velocity. Read along with me. It says this. Example 1. A 3,300 kilogram truck traveling at 18 meters per second in the direction 35 degrees north of east collides with a stationary, you know what, that's probably an important physics word. I'm going to underline the word stationary, 1,600 kilogram car. After the collision, hey, it's a collision. This is a job for conservation of momentum. The car has a speed of 15 meters per second due east. What's the resulting velocity of the truck? Is there a collision? Yeah. Are there angles and directions? So you know what? I'm a good physics nerd. I'm going to write a little compass rose somewhere so I don't screw this up. The first bit is going to be identical to Physics 11, at least the way I taught Physics 11. Is there a collision, Sam? This is a job for conservation of momentum. I'm going to write the sum of all the momentum before the collision equals the sum of all the momentum after the collision. That hasn't changed. It's a collision. And I ask myself the same question as I did before, Maris. I say, before the collision, what's moving? The truck, the car, or both? And that I can't teach you. You got to read the question. So before the collision, what's moving? The truck, the car, or both? The truck. So I'm going to go like this. Momentum. How about T for truck initial? Wham! They collide. After the collision, what's moving? The truck, the car, or both? Stuck together or separate? Separate. So I'm going to have momentum, truck, final, plus momentum, car, final. And again, you'll notice I'm putting vector signs because I want to remind myself that momentum is a vector, and here's where we kick things up a notch. I now pause, and in fact, I pause anytime, even if it's in a straight line. I ask, are there angles here, or is everything in a nice straight line? Soon as there's angles, now I'm going to veer off. So if there wasn't angles, I would let probably to the right be positive, to the left be negative, or if it was up, down, I'd let up be positive, down be negative, or whatever. And I could just go straight, basic high school math. Are there angles, Ryan? Okay, I'm going to dulp. I'm going to add tip to tail. I'm going to be very, very careful. So I'm going to dulp. It says the initial momentum of the truck. Ryan, can you read to me the direction of the truck's velocity initially? North of what? North of what? North of what? So I'm going to draw a dotted line going east first. What of east? How many degrees? Okay, so it's going to look like this. This is the momentum of the truck initial. Now, a common mistake kids make is they put the velocity on here. They go, 18. Velocity is not conserved. What's conserved is momentum, and momentum is mass times velocity. So what I'm going to put on this arrow is mass times velocity. It's going to be 3,300 times 18 equals 5,9,400. Now, I'll be honest, if I'm doing my homework, Halen, I don't put the 3,300 and the 18. I just put the 59,400. But in my notes to show you where it came from, I'll add that. Here, Rachel. Wham! They collide. There's my collision. After the collision, they're both moving. Do I know the truck's velocity direction at all? Don't know. Do I know the car's velocity? What? 15 meters due east. So it's going to be 1,600 times 15 24,000. I gave you guys a whole page for this, right? A whole half page because okay, good. What am I trying to find?
Good morning once again, everybody. At this time, grade 8s and teachers.
I'm trying to find that. In fact, I'm trying to find that. How would I get that by itself? You said the magic word. I heard it. What? In fact, over here, I can really say this. The truck's final momentum, which is what I'm trying to find, is the truck's initial momentum minus the car's final momentum. Is that okay, Rachel? Except I'm subtracting vectors. How do I subtract vectors? I don't. Who remembers? What do I do instead to be clever? Hang on. So I got to be fussy. Ashley said make it positive. Can you be more specific, please?
Make the negative 1 year subtracting.
Add. Can we say add the opposite?
Add the opposite.
I'm going to go, okay, you know what? I can turn this into a, like that. Okay, because now I have a vector equation that I can draw. Momentum, so I'm going to draw this one, momentum of the truck initial, plus the opposite of the car final. Now, this is the car's final momentum, 24,000 east. What's the opposite of 24,000 east? 24,000 west. By the way, don't go negative 24,000 west, because now you've done a negative, you've done an opposite.
Grade 9s and teachers.
So, let's draw a picture. Here we go. Momentum of truck initial looks like this. And draw a fairly large picture. It's 59,400 long. Now, if I was just adding these tip to tail, Emma, don't draw that, I would go that way, but I want to add the opposite. What did we say the opposite of 24,000 east was? 24,000 west. Now, I'm going to fudge things a bit because I can with digital ink. The 59,400 should be more than twice as long, so I'm just going to draw it a bit longer so it's closer to scale. And then I'm going to be clever. I don't like the number inside my triangle. I like the number outside my triangle. So if you want to with your pencil, you can do that. You don't have to. So what's the final momentum of the truck? Well, if you look, we said, okay, once you've written it as an addition question, the resultant, which is this, is always from the tail of the first to the tip of the second. Here's what I want to find. Oh boy, that's terrible. This is the momentum of the truck final. Okay. Is there a right angle in this triangle anywhere, Halen? So I'm not pulling out SOHCAHTOA or Pythagoras. The only angle they gave me was that one there. Sadly, Jake, that doesn't help me find this one. If it was a straight vertical line, the black line, then I could, but But I've showed you this trick before, haven't I? See the Z? So, that's 35. That's 35 degrees. I've got my triangle. Whew. I'm, by the way, Lisa, barely 1/3 of the way through the work right now. But at least I hope the rest becomes, with practice, somewhat mechanical, somewhat repetitive. Okay, I've agreed, Vanessa, this is not SOHCAHTOA, so it's either sine law or cosine law. Do I know both of those? No. Do I know both of those? No. Do I know both of those? No. You know what? It's cosine law. It's going to be momentum of the truck final squared equals, and what is the cosine law? 24,000 squared plus 59,400 squared minus 2, don't forget the 2, times 24,000 times 59,400 cosine 35 degrees. And then don't forget to square root. So now I'm going to go to my calculator. Those of you in pre-calc 12, make sure you're in degrees, not radians. Are you guys doing trig yet in pre-calc or not? Okay. Once you get to trig, you'll probably, at least for some of it, be in radians. 24,000 squared plus 59,400 squared minus 2 times 24,000. Wow. Oh, square root. And I get 42,057.03. But I think 42,057, that's 5 sig figs. That's pretty good. No? Yes? Anybody else want to confirm with me? I see one nod. Again, I'm going to warn you, if you're not trying these on your calculator, you're setting yourself up for some ugliness on the test. So I'm going to go 42,057 units. Is this the velocity, Carly?
No.
What did the question, though, want me to find? Velocity. Okay, if I know a momentum, how can I find a velocity? Momentum is what times what? Mass times velocity. Oh, now divide by the mass. So here it is. V truck final is going to be 42,057 divided by, what was the math? 3,300. And I get 12.7 for 12.7. Is that a velocity? No. It's a speed. What do I need to make it a velocity? I need a direction. I need a direction. At. By the way, I should say, Logan, this question here with vector subtraction is probably tougher than I'd be comfortable asking you on a written. If it was straight adding, though, you're absolutely going to have those on a written. Well, I think what I want to find is this angle here. I think. But Sam, I think to do that, what I'm going to do is I'm going to find this small angle here, theta, that little tiny wedge angle there, and then do what to find the big angle? How can I find the bigger angle if I know a little tiny one? Add, more specific, add 35? Yeah, okay. So I'm going to do that, all right? This is really yucky because there are very few nice vertical and horizontal lines in this triangle. I only got the one, so I'm kind of having to work everything from there. So how can I find, sine law. Sine law. Over here, I can go sine of mystery angle theta divided by 24,000, what's across from it, equals sine of the angle that I do know divided by what's across from it, careful, not 12.7, 42,057. Now, I can use the 42,057. If you really want to be fussy, you could reverse your calculation right now by timesing by 3,300, and that gives you your original momentum back to like umpteen decimal places. You don't need to be that fussy, but sometimes I am. Okay, here we go. I guess theta is going to be, well, not theta, the sine of theta is going to be 24,000 sine 35 all over 42057. $24,000 sine 35 all over, answer button. That's the sine of theta, of the angle. How can I find the angle? Shift sign. 19.1. Theta equals 19.1. So am I going to go like this, Holly? Oh, what did you say I had to do? Add 35. Okay. Plus 35 degrees. It's going to be 54.1 degrees. What of what? North of south, east of west? What of what? Sorry? North of east. Oh, did the decimal not go? Thank you. 541 degrees, be a little confusing. Sam, this is really the fundamentals of RCMP accident investigation. Now, really what you'd be interested in is not the final velocity. You would like to know the initial velocity. You'd like to know if the person was speeding. But what you would do then is you would look at the length of skid marks. And if you knew the coefficient of friction, which you could measure from the road with an instrument, and the length of the skid marks, you could find the accelerate. You could find, V final is 0, because V final is 0 in any car accident. You could find the initial velocities of the cars after the crash, and then work your way backwards and figure out how fast vehicle A or vehicle B must have been traveling, and that's how you can decide whether to charge somebody or not. Here it is. Turn the page, or next page over. These are tough. I would consider that last one is an A+, or maybe even a bit beyond an A+ question, because it had subtraction in it. Once we had the triangle, then it was an A-level question because we had to find a yucky angle. Okay. 5 marks, because I stole this, I think, from an old provincial exam. A 2-kilogram mass moving at 4 meters per second north hits a stationary 6-kilogram mass. The collision takes 0.025 seconds. After the collision, the 2-kilogram mass is moving at 3.8 meters per second, 10 degrees west of north. A says, find the final speed and direction. I guess that's the velocity. B says, draw a vector diagram showing initial and final momentum. We're going to do that as part of our solving method. C says, find the force. Okay. Well, let's start. Don't quite know where I'm going to go with that find the force thingy, but let's see. All Are there angles and compass directions mentioned? Then because I've turned the page, I'm going to go north, east, south, west. You might have one already on the same page. Jake, is there a collision? You know what this is a job for? I'm going to start out, same old, same old. The sum of all the momentum before the collision equals the sum of all the momentum after the collision. Cool. Before the collision, what's moving? Mass 1, mass 2, or both? Mass 1. So I'm going to go momentum 1 initial. Bam! They collide. After the collision, what's moving? Mass 1, mass 2, or both? Both stuck together or separate? Did I give you guys, I can't remember, in lesson 6, the terms elastic and inelastic? Okay, so these would be what we called elastic collisions because they're bouncing off of each other. But not that weird perfectly elastic, which is obscure. Okay. Is everything in a nice straight line, or are there angles? Then I got a dulp. Halen, if everything was not in a nice straight line, so everything was in a nice straight line, I would just let, hey, to the right be positive, to the left be negative, or east be east be positive, west be negative, or up be positive, or north be positive, south or down be negative. I could handle that, and I could just subtract and add and go my merry way. Here, I'm going to dulp. So, 2 kilogram mass moving 4 meters per second north. I went mass times velocity in my head. Is that okay? 2 times 4. Wham, they collide. Do I know momentum? Oh, yeah, they gave me the 2 kilogram final. What's the direction? Logan, what's the direction of the 2 kilogram mass after the collision? I know it's 3.8 meters per second. What's the direction? Can you find it in there, kiddo? The whole, in front of it. The angle too. Read the whole thing now. No. After the word and, the whole direction, because you just gave me... west of what? West of what? So I'm going to go north first. What of north? To the left. How many degrees? Okay. 10 degrees. How big? Mass times velocity. I can go 2 times 3.8 in my head. 7.6. I hope. Now, I could do the subtraction thingy because it is technically I want to find momentum 2 final, but this one's a bit nicer. And the reason this one is a bit nicer is my initial momentum is dead vertical. This would also work if it was dead horizontal. Unlike the previous one where my initial momentum was yucky at an angle, here I know what these two are supposed to add to. Apparently when I add these two together, tip to tail, I have to end up with a vertical. So you ready? Put your pencils down and watch. Actually, 10 degrees is far less. Okay, 10 degrees. Be more like that. 7.6. There is a decimal there. Okay. How must I draw momentum 2 final, the mystery vector? How must I draw it so that when I add it tip to tail to the 7.6, the resultant is going to be straight up? Can you see the only way that works is if I go something like that, and I don't go that far, and I don't go that short, because this is dead vertical, I know that, you know what, the mystery momentum. Now, what I'm not sure of, Jake, is it really steep? Or is it really shallow? Okay, I'm guessing there, totally. But I do know it's got to go up and right, north and east. So I'll kind of, I guess, well, like that. That's a little too far, isn't it? And I know the resultant is 8. And here is my momentum to final mystery momentum. Kyle, you okay with how I reasoned that out? You could also still use the subtraction trick, but this time we can kind of, because we know what the answer is supposed to be, and it's a nice vertical or a nice horizontal line, I can figure that out. Oh, and I have a 10-degree angle right there, don't I? SOHCAHTOA? Noah. Pythagoras? No. Cosine law. You know what? It's, if you wrap your brain around the cosine law, it sure is handy. By the way, you can also, and I think I mentioned this in the last lesson, you can also do this whole thing with components. It's way longer. Easier, yeah, and if you want to, come in after school and I will walk you through it with components. You can do this whole thing with nothing but SOHCAHTOA. But the cosine law exists as a great shortcut, so I'm going to use it. It's going to be momentum to final squared equals 7.6 squared plus 8 squared minus 2 7.68 cosine 10. Oh, no, that's not right. Square root. It's going to be close to 1.41. Because I know the square root of 2 is 1.41, and this is really close to 2. That one wasn't that impressive, believe me. 1.41, I'll carry it to 5 sig figs. I'll go 1.4168. Is that what they wanted me to find? No. That's the momentum. What did they want me to find? Be nice if I knew momentum, if there was an easy way to find velocity. Oh yeah, divide by the mass. So, velocity to final is going to be... Is that okay, Shelby? You were looking puzzled. Am I wrong?
No, you're right.
Sure, because I make mistakes occasionally. It's been known to happen fairly often. Well, I guess I could divide by 2 in my head, technically, because it's dividing by, the mass is 2, but we'll use the calculator. You get 0.708? Oh, am I doing the 6? It's momentum 2. You know what? I was looking at the 2 thinking it was the 2 kilogram mass. It's 6. You're right. Well, that makes it a little tougher. Bring that back. It's been known to happen. Oh, sorry. Occasionally. Do you get 0.236?
Yeah.
That looks better. Meters per second at, if I'm lucky, that matches the answer up there. Hey, it does. I need a direction. Can I use that angle right there? Why not? You're right. No, I can't. Why not? Okay. It's a nothing of nothing. It's not a north of south or an east of west or anything like that, because the top part of the angle is not horizontal or vertical. The bottom part of the angle is not horizontal or vertical. You know what? I bet you those have fancy names. I just thought of that. And I don't know them. I have to look that up. I bet you there is a name for the top part and the bottom part of two rays that make up an angle. If there isn't, there should be. Maybe I can name them. I'll call the top one Carly and the bottom one Ashley. So Carly and Ashley, neither of them are anywhere close to normal or vertical. Oh, that came out wrong. Well, okay. Anyways, so what I'm going to use is this angle right here. I'm going to add a vertical line, which I can, and it's going to be east of north. Problem. That angle is not in my triangle. Or is it? Is it in my triangle? Zorro strikes again. Right? So I'm going to find that angle inside the triangle using the sine law, but it's going to be east of north. Okay. Sine of mystery angle over 7.6 equals sine of 10 over 1.4168. I guess it's going to be 7.6 sine 10 divided by 1.4168. By the way, I'm using the answer button because, like, when you weren't paying attention, times it back by 6 to get the original back again. Oh, that's the sine of theta. Inverse sine. I want 68.7 degrees. What of what? North. No. East of north. By the way, that's part A. 2 more to go. Well, B says draw a vector diagram showing the initial and final momenta. And momenta is the plural of momentum. It's not momentums, although you can say that if you want. Justice, I'm going to argue, I think I already did. In fact, really, I'm just thinking to myself, next year I might flip A and B around or something like that. C, find the force on the 2 kilogram mass during the collision. Find the force on the 2 kilogram mass during the collision. Any suggestions on how I could do that, folks? Pardon me? Ashley said momentum divided by time. I have to be fussy. Technically, she's wrong because there is no equation that says momentum divided by time. Change in impulse divided by time. Okay, that means I'm going to need 2 momenta. So I'm going to go like this. You know what? Okay, so I guess the force is going to be the change in momentum over time. And what's change in anything? Oh, crap, Mr. Dueck. Are you telling me, Mr. Dueck, are you telling me that I've got to subtract vectors? Wait a minute. What was the initial momentum of the 2 kilogram mass? Is it 0? No? Now I'm wondering, did I want the force on the 2 kilogram or the... So it wasn't. It was 8? What was the final momentum of the 2 kilogram mass? Boy, this is going to be yucky, Mr. Dueck. This is going to be, okay, 8 north. 8 north. Okay, we're going to have to subtract vectors here. This is going to be 8 north. Sorry, what's the final momentum? 7.6. This is the final momentum right here, right? Let's delete that, though, because that really gummed up my drawing. This is the final momentum, 7.6 kilogram meters per second, 10 degrees east of north. West of north, that's what I said. Boy. So here's the final momentum. Yoink. What's the initial momentum? 8 kilogram meters per second north. Except, Ashley, we're going to go like this, plus negative. So what's negative initial momentum?
South.
Boy, 7.6. The 8 should be longer, shouldn't it? The resultant is going to be from the tail of the first to the tip of the second. There is the change in momentum. Sheesh. Good thing I left a whole page. Cosine law. The change in momentum squared is going to be 8 squared plus 7.6 squared minus 8 squared minus, good gosh, Dueck, 2 times 8 times 7.6 cosine, oh, wait a minute. Zero strikes again. Thank goodness. That's also 10 degrees, which means my diagram is terribly scaled, but that's okay. Yo, am I wrong somewhere?
Well, is it not just the same as our first?
What? What's that?
The final momentum
Yeah.
would be the same number?
Won't it be the same number? You mean I'm doing the same equation over, where am I? Same equation right here? Yeah. Oh, this is nice. So there's a little bit of a shortcut here. Okay. Momentum 2 final, it's going to have the same magnitude. Good. So the change in momentum is going to be 1.4168, which means the magnitude of the force is going to be 1.4168 divided by the time. How big was the time? 0.025? $56.7 newtons? Oh, but they also wanted a direction because it's a force, which is technically a vector. So 56.7 newtons. Now here's the nice thing, Antle, you're right. With cleverness, I think I can say, what do I want? South of west is what I used, did I? or west of south? South of west, I went 20. Oh, and I used a different angle up here, didn't I? I said 68.7 degrees east of north, which is 21.3 degrees north of east. I think I can make the argument that this angle right here, is the same as this angle right here. I think they're symmetrical, what are called similar triangles, like they're congruent triangles. So I think I can say at 68.7 degrees, but what of what? This is west of south. Wow. Whew. Wow. How many questions did I give you? 1, 2, 3, 4, 5, 6, 7. I don't think they're all as bad as this. In fact, I think they're a little better. Okay? So what's your homework? Try these. I'm noticing number 1, I didn't give an answer. Or is number 1 the same question that we did, Mr. Dueck? No, I changed the numbers. Okay, number 1, apparently I didn't put an answer for some strange reason. 2, there's an answer. 3, there's an answer. 4, there's an answer. 5, 6, and okay. Lots of practice. This is tough. And remember, Logan and Halen and Michael, who came in late, I didn't mark this quiz at the beginning of class because people who didn't have it done, get it done for next class for sure.